The third type of asymptote that you may see is what we call a slant asymptote or an oblique asymptote, depending on which textbook you use. A slant asymptote is going to occur, obviously, at a slant. It's not going to be a vertical or a horizontal. It's going to have a slope. So you will find the equation of that slope and your y-intercept, so you can name that slant asymptote. All right, so how do I identify them? It's a little more complicated. Okay, so that oblique or slant asymptote is just a slanted linear path that the function, again, will follow it as the graph is approaching positive or negative infinity, depending on which side you're looking at. It's only found on rational functions when the numerator is exactly 1 degree higher than the denominator. And what you can do is just use polynomial long division, and whatever your non-remainder part is, so just the quotient part, don't worry about the remainder, the quotient will be the equation of that asymptote. So as long as you have that 1 degree higher, then you're going to be good. So let's look at some examples. All right, so here's an example where we have our numerator is exactly 1 degree higher than the denominator. All right, so what I'm going to do is I'm going to do this long division, right? So and if you need a refresher, please go back and watch that video that I have on long division of polynomials. Will definitely help. All right, so here is my second degree. It's just 2x squared. So there's no x value and there's no constant. So I'm going to put in some placeholders for those. And then my divisor is 3x plus 1. Right, and then I'm going to do this long division. So what do you have to multiply 3x by to get 2x squared? And this is where people usually go, I don't know. So it's going to have to be a fraction. It's going to be 2/3 x. When I multiply 2/3 x by 3x, I'm going to get 2x squared. And then 2/3 x times 1 is positive 2/3 x. And then you're going to subtract all of that. Subtract this, subtract that. Notice the leading term is going to fall away, and that's what you want. And you add those together, so again, 0 minus 2/3 is negative 2/3 x. And then bring down your next term, which is plus 0. And then repeat the process. All right, so what do I have to multiply 3x by to get negative 2/3? And the answer is negative 2/9. So negative 2/9 times 3x is going to give me negative 2/3 x. And negative 2/9 times positive 1 is going to give me negative 2/9. And then again, you're going to subtract all that. So you're going to subtract this. The leading terms are going to fall away, which is what you want, and you're left with a remainder of 2/9. Do not worry about the remainder. Okay, so this is going to be the equation. So this is going to be your slant asymptote. So your slant or your oblique, depending on what your book uses, is going to be y equals 2/3 x minus 2/9. So your graph is going to end up following that line. So notice here, here's the graph. Notice here is my slant. And notice how the rational function just kind of nestles down between that vertical asymptote and that slant asymptote on both sides of this graph. So very important that you double check yourself, and using a graphing utility is perfect for that. All right, one more example. Again, has to have exactly 1 degree higher in the numerator, which it does. If it doesn't, then it's not going to have slant asymptote. So I wouldn't do any of those examples because then we wouldn't get to do all this lovely long division. All right, so let's do our long division. So my dividend is 2x squared plus 3x minus 1. And I'm going to divide that by 2x plus 1. All right, so 2x times x would give me 2x squared. So multiply all that out, and I get plus x. And then again, you're going to subtract that. Leading term's going to fall away. You're going to get 3x minus x, which is 2x. Bring down your next term of minus 1. So how many times does 2x go into 2x? It goes one time, right? So plus 1. 1 times 2x is 2x. 1 times 1 is positive 1. Again, you're going to subtract all that. Subtract. And you're going to get an answer, remainder of negative 2. So again, don't worry about the remainder. We're not dealing with that. So my slant asymptote, the equation of that is going to be y equals x plus 1, just your quotient. So that will be your slant asymptote. So You've now discussed all three ways to find your asymptotes, and that is going to be a great basis to help us graph these functions. So make sure you come back next time when we start talking about graphing these rational functions.